Okie dokie, it's actually working this time. This is good. We just stick out the announcement. Okay, so Twitch streaming is working for me now. Doing a live stream working on improving VBCC support for the MEGA65. HTTPS twitch.tv MEGA65 poll. Right, copy that so I can hit send a do on there. We'll see whether anyone comes on. It's a bit of a random time. But if not, you join us after, then yeah, hope it's enjoyable as well. Let's go to Twitter. Tweet. And that's it here as well. Hey, and welcome along to the three of you that have hopped on already. Say howdy in the chat. Love to see who's lurking about while I get my HDMI connection here so we can see what I'm doing a bit more, because there'll be a fair bit of typing away on the Linux system for this since we're working on the thing. Oh, howdy Robear73 and another Adelaidean, fantastic. Hey Amok, yeah, no, thank you for the kind words. So yeah, I am recovering from the surgery, so it's kind of, yeah, this morning wasn't so fun with a fair bit of pain and nausea, but I've got some anti-nausea meds and the pain's improved a little bit, but it's fun streaming with you guys anyway, but it's a nice diversion for me as well. So yeah, so let me see what we can get here. Blah blah. Right, and I need to do that so I can see what I'm doing. So what the goal is today is I want to do a little bit of work on the VBCC compiler. So this is a C compiler that supports a variety of interesting machines. That's right, Mox says the shame he doesn't remember what VBCC is. So it's a C compiler written by Volker, and I've forgotten his last name at the moment. The meds aren't real great for memory. VBCC C compiler. I'll try and bring up a web page here to show you, because you won't be the only one who's wondering. So it's known on some other systems, like on the Amiga and stuff. It's available, and he supports quite a lot of different systems with it. And he's been kind enough. Hey Ludon, great to see you as well, and Andy Magic Knight, welcome along. So yeah, he's made this really nice C compiler that supports a bunch of kind of retro systems and things, and we approached him about making a MEGA65 port, and we've arranged to do that, including for all MEGA65 users to have license to use it, because it's not a completely free compiler. It's open source, but not it's not like the GNU compiler collection where it's free to modify and distribute in that way. But what's really nice about it compared to CC65, which is kind of the mainstay C compiler for the C64, is that it tends to produce better code because it can do much better high-level optimization. So the code generator, it varies quite a bit as to what you're doing, as to what the difference will be. So I've got a couple of little toy examples that I've been testing with to check the performance of it. So I've got this, I'll show you what I've got here in my repo for it. So I've got a test script that tries to compile a few things. So we've got an empty program first up, and the empty program is really just so we can benchmark how long it takes, like how many bytes the C compiler has as overhead for a compiled program, because it's kind of set up code and stuff, and it's not really fair with small programs to include that in the measure, because otherwise, you end up, it's like when you buy fruit and veg, right? You end up weighing the bag rather than the fruit and veg in it. Then we've got color cycle that does some border color cycling, and primes, which does some simple calculation of primes, and then test log that displays the output of this in a nice kind of way. So this is all shell script magic foo. Looks like a pile of goo, but if we run test log, this is pulling the data out from the compiled runs. So I'm comparing CC65, also KickC, which we know, so KickC is not full C compliant. Hey, and welcome to everyone else who's kind of lurked along. There's 9 of you on there now, which is great, so always feel free to say howdy in the chat. It's great to see who's on. And VBCC, which is the one that we're working on. So what we see is the empty program, and I'll show you the empty program. If I got my... Where is my window gone? Need to drag that across. So the way that we do the speed test is I've got a special funny little CPU simulator for the MEGA65 that does cycle counting and instruction count, so we can actually see exactly how long the program will have run for and how many instructions it will have used and those sorts of things. And the way that it works, if you write to FFFE, then it goes, oh, okay, you want to start timing, and it times from there. So it skips all of the weird magic setup that the C compiler does in the timing, and it goes until you write to location FFFF. So if we come back to here, and Amok is saying something here. At some point, can we approach more or less the efficiency of ASM with such a compiler? Back in the days, I found myself producing less efficient ASM code than a standard C compiler on x86. So it's actually really interesting. On the x86, it's really hard to, and particularly on x64, really hard to produce hand-tuned assembly, which will beat a modern C compiler, because there are so many instructions. Whereas on the 6502, it tends to be the other way around, that determined users can typically still produce at least as good a code, if not better code. Now, if you want that performance out of C that matches hand assembly, you can actually see here that KickC is the one to go for, right? So it has the smallest, so the size in bytes, it is by far the smallest across the 3 tests. So it's anywhere from like 1/10 of the size for the empty one, right? Because KickC doesn't really do any magic setup and doesn't support command line arguments and all this kind of fluff, right? So it is lean and mean. There are reasons why it is able to be more efficient. And likewise with the color cycle. We'll have a look at the assembly for some of these in a moment as well, because it's quite interesting to see how the different compilers tackle these different jobs. And we can see that the empty one takes 4 cycles for all of them. That's simply because it all boils down to an STA FFFF somewhere, which takes 4 cycles. 1 for the opcode, 2 for the argument bytes, 1 for the register value. Because we tear out the writing to FFFE and getting the value ready to put into FFFF. In fact, if I really wanted to, I could have actually made it so that it subtracted the cost of that one instruction. It would have shown 0, but I didn't. And that's right. Oh, and welcome to the other 2 folks who've come along. Say howdy in the chat. So the color cycle one, this is quite an interesting one. So if we look at the cycles, it's really fascinating. So KickC has this tiny program, 27 bytes, to cycle the border colors a few times, and I'll show you the program. So we start the timing, we end the timing, and in the meantime we simply set the screen color to all of the colors from 0 to 15 once. So this is a fairly simple program, and what we see of course is that KickC is way tinier. VBCC is interesting, is larger, but look how fast the VBCC program is. And the reason for this is that the optimization flags that we have running on VBCC are optimizing for speed, not for size, as far as I can tell. And so as a result, loops get unwound. We can see as a result, like both of them are way faster than what CC65 can produce. When we come down to the prime number sieve, which I'll again yeah, so just calculate some prime numbers, right? And I can't even remember how large. Yeah, we have this is composite. And I can't even remember how this works. Oh, that's okay. We go through multiples, right? So we're adding the multiples. So we start by saying it's 0. And we're not worrying about doing P0 because it's actually implied from the beginning. So again, pretty simple. Hey, Twitch Eagle, welcome along. Thanks for saying howdy. So again, we see with that one, Kixi produces the smallest code, and in this case also actually the fastest code. VBCC again is a bit bigger, but also a bit faster. And so what I'm expecting as we go along, hey, welcome along, Pink Puff as well, great to have you along, is that more complex programs I think are going to get more efficiently optimized by VBCC, and at some point I'll have a dig through the optimization options for it to select size over speed, because in a lot of cases actually it's the size we care about because we're memory constrained. Now, one of the other reasons for wanting to improve the VBCC support is that VBCC supports memory banking. Now CC65 does as well, and so we could also add it in there, but as I say, my feeling is that VBCC is going to give us better overall performance, and it supports newer versions of C and things, so this is a little bit easier to work with. Twitch Eagle says, was chatting with Proton Fig and listening to music while working. Cool. And on that note, actually, hopefully, we should have a decent audio level for the background music. If it's too loud, let me know, and I can twiddle it down a bit. It depends a bit on what songs are playing on Radio Parallax. So that's the framework. Cool. Thanks, Twitch Eagle, for confirming the music volume is okay. So now what we need to do, if we want to support programs that are larger than 64K, is we need to have a memory layout that works for that, and we need to have a loader that can load those programs in. Ludon says, interestingly, if the optimization method would be selectable for a code region, so you could tell a compiler that a certain function needs to be optimized for speed and others for size. Yeah, so I think that's possible because you can compile each source file separately, and you could give different optimization args, and then the linker will link it together. So again, because it's a C compiler and linker, it will do that kind of thing. So hey, Shalon, welcome along. Great to have you along. Normally it's the other way around. I'm watching your streams. So yeah, great to have you tagging along. And yeah, so what we need to do is have something that can load the banking file from a D81 or from the SD card directly. Yeah, Shalon says, benefiting from the technical issues you had. Yeah, so for those who don't realise, I was going to go streaming before when Shalon was finishing streaming some game playing earlier with the Lego Star Wars, I think, wasn't it? And for some reason, I'd hit the on-air button on the Atom Mini Pro and it just wouldn't work. And I tried it again a few hours later tonight, and it's like, oh, it's all working again magically. So, yeah, who knows? So yeah, Skywalker Saga is the one that Shalon was playing, which looks pretty fun. So, within the VBCC compiler, just to show you a little bit how I've got the layout here. Okay, so we've got VBCC, which is the C compiler, VASM, which is the assembler, and vlink, which is the linker. Whoops. So in VBCC we have targets. Oh, I need to, it's blasted. Don't know why the ATA Mini Pro on my foldback monitor here, it cuts off the edge of the screen, so I can't have things, I can't just hit maximize. It's really annoying. So it's a modified 6502 target, and it's also made a pure C65 one, but at the moment we're interested in making the MEGA65 one work. So I've been modifying the linker file which defines the memory layout. So the default one, if you're not using banking, so it has a 2 kilobyte C stack at B800 to C000, and then you've got RAM available from 2001 to 2001 plus 97FF, so up to B800. And then, yep, it's laying out all the RAM stuff, and it all goes out into the standard image. So that's what we have for that one. For the banking version, and I've already modified this a little bit from what Volker had originally set up. So I've put the stack down in low memory, below 2000, so that we don't take away from the available space. And I've just realized I've got a major typo in there. I want the page size to be 4000, so 16 kilobytes for the banking pages, and I want them to be, whoops, at 8000. And then we've got the main memory is at 2001 and goes to 7FFF, so it's 24K long essentially. And then the way it implements it is that we have the REU file. I have to find out whether I have to put the stack somewhere else. I'm not really sure. We'll find out with the sections and things, because I'm not really familiar with how this linking file works. So if people spot stupid things that I'm doing, that would be fabulous as well. So then we can have an REU file. So this is where the banking memory goes. And again, because it's based on the C64 target, that supported REU. So the Commodore RAM expansion units. But of course we'll be using the map instruction to do the banking. And this is why the page size is a multiple of 8K. We're doing 16K. And the reasons for that will become clear in a moment rather than 32K. And then we're allowing at the moment 16 pages, so we can have 256K of banks, and we can easily add more banks in than what we have here, right? Because at the moment this will only use 256, so 16 times 16 kilobytes of banked RAM plus the first 64K of RAM. And yeah, will be a little bit interesting. And in fact, what we haven't got in here is the ability to use that upper 32 kilobytes of the first 64K of RAM, which in fact we can use by not mapping it. So Pink Puff, yeah, so this compiler does support C64, as does CC65 and KickC. And what we're doing now is we are extending it to support the MEGA65. So you familiar with what we're doing with the MEGA65? I'm not sure. I presume you are, but if you're not, let me know and I can do a quick intro on that. So then the RAM file is the main program, so that all gets pushed out to RAM. And cool, yep, so you've got one pre-ordered. Excellent. That's right. It's just because sometimes we get folks who kind of drop in on the streams, which is fabulous, who aren't familiar. And we can see that the bank files all go out into the REU file, which is all fine and good. And so that should mean, if I come back up here, so we have our tests directory. I'm just going to remove the .b0 files because I reckon they're hanging around from before I modified this. And we should end up with 256K B0 files. So I'll run the test script again, which will compile everything with all three compilers. And we see our things there. Right, so now our B0 files are 256K. So that's good. And I didn't pay enough attention to see whether the relative sizes changed much, because when VBCC is in banking mode, it has to add some extra routines in to allow switching between banks, but it might be clever pants enough that it is not including them because they're never being called, because all the code is in one bank. It should be fine. So what we want to do, no, we don't want to see me in close up. That's which camera is it? Nope. Haha, that's better. We'll blame it on the meds. So if we load we just want that. So this should, whoops. Okay. I have to find out why it's doing this. This is using M65 to push the thing across. So if we haven't screwed things up too badly, this should run and it shouldn't crash. Now, of course, the program will only cycle through the colors once, right? And then it will terminate. Yes, a cross compiler, Pink Puff, absolutely. So this doesn't run on the MEGA65 itself natively. I'd love for us to see something like TinyC ported to the MEGA65. I reckon it'll be possible, but to compile it natively, we need something like this C compiler to do it. Sheldon 50K here, M65 to lowercase, intended behavior. Yeah, correct. And we should be able to, in the matrix monitor, oops. Find the code. We can already see that there's there. So it's calling 2032. So again, we have to get past all kind of the magic setup fluff, but we should somewhere find here where it is doing the border color changes. And I can't. Oh, here we are. There's. Yeah. So you can see here it's unrolled the loop, right? So it's writing all of the border colors. So what we might just do, just for our sanity, to make sure that that's actually working, if we come back to here, and we do while one colors. So now it should endlessly change the colors. Now the trick is I haven't got a nice, because this is going to try and simulate it, right? And it'll never end because it's got an infinite loop. But we can still run our script to compile it. Compiling, and you can see now that the simulation is going, oh, this is going on for a very, 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 very long time. I think it does eventually give up if it never actually stops. So if we okay, so I've reloaded it and it shouldn't do that. It should be showing us things. So we're going to stop the CPU and see where we're up to. It's working. Now, I can tell you why it's not displaying anything. And that's because in this default memory map, there is no I/O visible. So remember I was talking about the memory map and only having 16K for the page. So what we had before, so this is how VBCC was set up before. So that's the low RAM, which isn't being used for anything in particular. And then we have, where are we? 7 FFFF is equal to program, and then 8,000 to banked RAM. That's what we had. Exactly, Ludon, you have it correct. There is no I/O mapping. None at all, in fact. So what we want to have is something that is more useful for us, right? So we have, ZP, whoops, CPU stack, etc. We want to have screen, and then I'm proposing that we have that's the C stack. We might talk a little bit later about what the C stack does. And then here is utility area. So we may still allow you to have utility programs later, or it might be that's where I actually put the loader and the banking thing. Oops, that should really be 1FF, right? And then we can go to 7FF with the program bank 0. And then what we want to do is have 8FF to BFFF available for banked code / data. And stick some variables in C000. IO, currently lacking. We can have more variables at EOOO to FOOO. And then we can put CPU vectors down here. Now the reason for doing it this way is we want to be able to reuse the 128 kilobytes of chip RAM that the ROM occupies. Because in a C program, we don't need the basic interpreter. So we can just ditch all of that. The flip side is that we will need to have our own disk routines, which is what I'm going to be working on. So to get to that point, so we need to fix this mapping so that the I/O is visible, and look after a few other bits and pieces in there. So that's probably what we will work on in the first instance now. We'll try and get that I/O map working so that the color cycle program does what we expect it to do. Okay, back across, let's pull up code. Okay. So this is the startup code that gets added in to do everything. So let's have a look and see what it's doing. So this is the basic header with the SYS 8213 and the bank in the opcode, which is this one. So saying bank 0. And I think it's the bank 0 that's mapping out the I/O. So we can do something about that. So, okay, so we're disabling interrupts, that's all fine and good. And eventually we want to actually clear interrupt sources. And apologies if I'm fidgeting around a little bit, it still have a bit of pain here, so I just need to make myself a bit comfy. We want to start with no mapping. Whoops. So, whoops. I'll let the editor do the indenting at once. Switch to, whoops, sorry. Disable all RAM banking. We then want to disable VIC3 ROM banking, which we'll do in a moment. Then we want to enable C64 style I/O mapping at D000. which has less zeros in it than that. Oh, there's one. Okay. Yep. Oh, that's interesting. So this is to map in the IO area, but that's okay. So that's incorrectly done. Okay, we'll move that down there. So in fact we need to do this in the right order. We need the IO mapping before, and this might be why that some of that wasn't working. So let's just do this in the order that seems logical to me. Set CPU to full speed. Disable RAM banking. Now I can never remember the values that we have to put in 0, 1 to have I/O, but no kernel and no basic ROM on the C64. If anyone knows at the top of their head, and you can beat me to finding it with an internet search, let me know. Banking. Memory management is probably what we're after. And there should be the nice table, right? So we want IO, RAM, and RAM. So we want 35 in there. Cool. Now we probably should make sure that it was with the correct directions. Not that it should have happened, but you know, that's fine. And now we need DO30 or DO31. So this is the ROM stuff, right? So we want to mask out bits 3, 4, 5, 6, and 7. Well, actually, 3, 4, 5, and 7, right? Seven, 3, 4, and 5. That looks like 8 bits to me. So we use the TRB instruction, which I love. That clears the bits that are set in the accumulator in that register. So here's a question for folks. Should we set to lowercase or not? Or should we leave it uppercase? I always find it a little bit odd when C changes that automatically. If it's going to do that, I'd probably actually just load an ASCII character set and be done with it. So that if you want to do traditional C-like things, you would just tell it you want the character set. Now we need to put, so once we've enabled the IO, then we can do that. And we've already done, oops, that. And yes, so this is just doing a bit of a loop, right, to erase the BSS. So that's the variable area. That would probably be better done with a DMA job. Oh yes, you're absolutely right. We haven't got an EOM after the map. Well spotted, Ludon. Yeah, and I agree. I think a con.io function or something to, you know, so So we disable interrupts up here, and mark end of mapping to allow interrupts. Now what we haven't done yet is to set the interrupt vectors in there yet. Now let me just check, someone's just sending me a message. Oops. Right, so in theory that should all work. So we need to recompile that, which I think we have to do using VASM. Okay, startup. Aha, okay. We're going to have to look at the VASM man page and see what's happening there. VBCC PDF. There's probably some magic foo that we have to do. Oh, and this is not the right version because it's not got. Oh, I know. I should get the one out of where I'm building from. Open. VASM. Yeah. Okay. Make doc PDF. Oh, it was already there. Open doc VASM.pdf. Okay. So CPU, let's search for MEGA65. Enables the MEGA65 instruction set. That's what we want to see. Yay! And so that a.out, I think we need to move a.out into VBCC targets, MEGA65, lib. Oh, and it needs to. Okay, I need some other option on there to compile it as a .o, don't I? How do I do that? Maybe it is. Nope. Anyone can beat me to finding this, that would be more than welcome. Okay, general assembler options. Okay, what have we got here? Okay, so -O will tell the name of the file, but we need... Oh, let's see, I can't see it in there. Because there's no make file in here, right? I'm just trying to work out how we get the assembly to give the right format. So we want 602 M65 lib startup.o. Excellent. So it's a VOB. And what did we get from, maybe it's the right type. No, that is definitely not the same type of file, right? Not just... no. Okay, there has to be an option that does this. On the basis that they've been built. Oh, right, okay, we do -F VOBJ probably. That looks more promising. Yes, that looks good. Okay. Right. Let's try and compile that again. And again, we'll infinite loop. But reassuringly, it looks like it's trying to run. So let's try and do M65-F tests color cycle.vbcc.prog. And it should run when I tell it to run. Oh, look at that. We have IO mapping and everything in there. So sweet. That has me very happy that we are on the right track. So I should commit those changes before we lose them. Bank in, I should do both files, right? Set up memory map with IO visible, etc. I don't know if you can hear that rumbling noise that just happened. That's possums on our roof. We have stacks of things. That's right. Yeah, sorry about your eyes there and everything. And yes, the compression algorithm will have had a hernia with that, I'm sure, because every frame is completely different to every other frame, essentially. Because I should be able to actually see. It might even actually be the ATEM Mini Pro that it's just because the. I'm actually going to run it again just for my curiosity to see what the data rate is on the Mini Pro from that when it's streaming at the moment. Anyway, set up IOMAP to be visible. And Oops. But first, we'll just finish committing the stuff. Fix typos in MEGA65 banked memory layout. Git commit run a test. Use MEGA65 banked layout by default with VBCC. Okay. Blah blah blah. Not too worried about the rest of the stuff that's not being tracked. The color cycle, yeah, we don't want that change to be permanent. But let's do our F tests color cycle VBCC dot prog again, and oh, what's it screwed up? Yeah, so it looks at fresh opossums right from the roof. Well, so common misconception. So possums and opossums are different creatures. They're both probably just as annoying as each other. The Australian possums certainly are. And the what's frustrating, of course, is that they are protected. And now, of course, I'm talking about possums and I'm watching the data rate spike up, so you're going to see horrible lag things happening here. So the data rate's gone up to like 10 megabits a second, and it's choking. Ooh. Ah, yes. So it's frozen with run stop restore there because that will have triggered an NMI, and we don't have an interrupt handler for it, so it's crashed the machine. This is what we expect to see. Right. Okay, so where are we up to then? So we now have a working memory map for it. We haven't tested with the banking, and I haven't started with the disk loading routines. Oh, and welcome along to all the other folks that have snuck in. There's 18 of you on there now, so feel free to say howdy if you haven't already. I probably am going to have to hit the sack in a moment. It's nearly 9 o'clock at night here, and I'm still tiring quite quickly. But yeah, happy that we've got the memory map working. I thought that might have been more pain than it has actually turned out to be, so that's really nice. Hey Judge Strock, welcome along. And yeah, hopefully tomorrow even I might do another stream or two and start trying to make the loader for the .b0 file, so they can be loaded from a D81, so that we can compile a VBCC program directly onto a D81 and have it load nice and quick from the SD card, and acceptably fast from the mental blank, the actual floppy disk, using my IRQ loader. And I'll probably in fact install the IRQ loader as an IRQ loader, so that your program can be doing some initial things while it's actually loading in the banked memory, and that the loader can keep track of how far through it's loaded, and it can do blocking banking, if that makes sense. So if you've only loaded up to bank 3, and as long as you don't call any functions that are further along in memory than bank 3, they'll run. So you could have the intro part of your game, if you want to make a game for example or something, and that could be all working, or you might have later levels that are in different banks, whatever, right? And that will then be available once it's loaded in. And I think that would be quite a nice way to have it. So that's my thinking at this stage, because my IRQ loader is less than 2 kilobytes, so we could actually fit it in that space from 1800 to 1FFF without it really impacting on things, and that would be really, really nice. Cool. Yeah, and Judge Rock says, counting the days. Yeah, we're really looking forward to the seeing the boxes arrive, and from what I understand, Trent has got everything all pretty much set and organised now to once the boxes come, that they just need to pack everything in and get everything ready, which will be really fantastic. Yeah, so Shalon says, once I get back to MEGA65 code, I need to chat to you about booting directly from an SD card, like a game cartridge type thing. Yeah, so that's totally doable as well. So you could have in the external SD card slot on the MEGA65, that takes priority over the internal SD card slot. So exactly, so you just need to make a stub ROM that will do whatever you want. So the good news is you can actually make that just be a C64 style stub ROM, because the MEGA65, like the C65, actually starts up in C64 mode, and it decides whether there is a reason to stay in C64 mode or whether it should escalate up to C65/M65 mode. So yeah, you can basically just make your own pretend kernel to handle that. And so using some of the stuff from the Open ROM would be one way to do that, or you could actually just make your code just go shebang and load in, and then you just want to make sure that you've got routines on there for doing the direct SD card loading. That said, I think it would actually still be more fun to actually make actual cartridges, but you know, there's different approaches and everyone can do their own different way, and that's actually really nice and cool as well. So yeah, so I reckon I'll leave that at that for the moment. Nice little piece of progress. It's nice to kind of have that off my mind, knowing that we can produce that code and have a reasonable handle how the linker config works. And yeah, that should be good. What I might do as well, I might actually make it so that we have a bank model that allows yeah, exactly, to fill up the entire 8 meg quickly. That's right, so the SD card will do that very quickly. You could also make something on the cartridge port that would also fill it up quite quickly. So we can do clever things with that. But also we can, with this banking with VBCC, have the first, you know, whatever it is. So there's 384K of RAM, 64K is in the first bank, so there's 320K of remaining RAM. So 320 divided by 16, so that's 20 banks of chip RAM, and then we could have another bunch of banks, which are another 512 banks in the attic RAM, the slow RAM, and have some magic ways to handle that. And it might be that by convention you don't have predefined data in the banks that are in the attic RAM, but they can be addressed and accessed. So that would let you have, you know, 8 meg of large data for a program. So for example, if you're doing a C compiler native, that kind of thing will be really, really handy. So yeah, no, so happy that we're headed in the right direction. Cool. So I will leave it at that, folks. 9 o'clock here, and I'm going to turn into a pumpkin. So yeah, we'll catch us around. Enjoy the remainder of your weekend, and possibly see you sometime tomorrow. Okay, see ya.